Hi everyone, I'm Kristen Henderson from DDS Analytics, and today I will tell you about my analysis of your employee attrition data. So first I'll take you through a brief description of how I did the analysis. I'll go through the top 3 factors leading to attrition. I'll tell you about a model for predicting attrition that I developed. I'll give you a short demonstration of an interactive app that allows you to visualize some of the trends in the data. I'll talk about another model for predicting monthly incomes. And lastly, I'll go through some recommendations that I have. So I started by plotting each variable to compare the attrition groups, and the variables listed seem to show differences in these populations, particularly these 4. And for example, let's look at the proportion of attrition in each job level. If we look at job level 1, the red bar at the bottom, over a quarter of the employees in job level 1 leave the company. And this is 13% higher than any other job level. Now, to illustrate an example of a variable lacking evidence of an association with attrition, we can look at gender. And if you look at the attrition rates between males and females, they're virtually the same. So next I ran statistics on each of these 21 variables, looking for evidence of differences between the attrition groups. And this list, including the 4 starred variables, had significant differences below the alpha 0.05 level. And from this list, I identified a subset of 3 variables that, when used in a predictive model for attrition, achieved the highest specificity. And what I'm referring to with specificity is the percent of instances where attrition is correctly predicted. And so these top 3 factors leading to attrition are job level, monthly income, and overtime. This plot illustrates the positive relationship between job level and monthly income. It reveals a large income gap between the employees that stay and those that go, specifically in job level 4. And also in job levels 1 and 3, it shows a small trend of attrition with lower median incomes. Now, if we look at the employees that do not work overtime, attrition rates are very low. They're under 15% for job level 1 and under 10% for the other job levels. However, when we look at the employees that work at least 1 hour of overtime, the story totally changes. And over 50% of the employees in job level 1 that work overtime leave the company. This pattern holds true across the other job levels with the exception of job level 4, where attrition rates more than double. For predicting attrition, this set of variables produced the best model. I used them in a naive Bayes model, and when I evaluated that model, it achieved a sensitivity of 83%, which is the percentage of correctly predicted employees that stay, and it achieved a specificity of 67%, which is the percent of correctly predicting employees that leave. And I used these same variables minus job role in another model for comparison, and that was a KNN model. And when I evaluated this model, the sum of sensitivity and specificity were nearly equal to the naive Bayes model. And what this indicates is that the predictions aren't dependent on the model, but on the data itself. So I'm going to play a short demo of this interactive app that I developed. I'll start it now. And what this app does, it displays the distribution of monthly incomes for each attrition group for any individual job role or any combination of job roles. And you can specify the income range that you're interested in and the specific job roles that you'd like to see. And as you change those parameters, it updates the percent of attrition and the distribution of monthly incomes. The link to this app is on the last slide of the talk. So in addition to predicting attrition, I developed a linear regression model for predicting monthly income. And these 7 variables achieved the lowest error rates. My error metric was the root mean squared error, or RMSE, with a target of less than 3,000. And for the RMSE, the lower the value of, the better the model's performing and the lower the error. So when I used the training data to evaluate the model, it achieved an RMSE of 1357. And more importantly, when I then used an independent validation data set that the model had never seen before, the RMSE was very close, at just a little bit higher at 1382. So based on my analysis, I have some recommendations. I recommend increasing monthly pay for job level 4 workers earning less than 14,000. For the other job levels, a reduction in overtime. And for job level 1, prioritizing salary increases and advancement. And my email address is listed here for you. If you have any questions or would like any clarifications, please reach out to me. There are additional resources and data available on the GitHub repository. And the interactive graph that I demonstrated, the link to that is the last link on this slide. And thank you very much for your time and attention.